Alright, Foundations 2.6, linear inequalities in two variables. So basically steps for graphing an inequality is really no different than what it was with graphing an equation, except for a few minor things. First one, remember, you graphing inequalities was one variable, you write it in slope-intercept form, get y by itself, and then graph a boundary line. Now here, where before you had just a standard solid line, whereas with an inequality, if you have a dashed line, if it's going to be less than or greater than. So if it doesn't have the equal to part of it, then it is going to be a dashed line. It is going to be a solid line if you have, if it's equal to as well. And then you shade above or below the line. Easiest way to do this is if it's greater than, you want to shade above the y-intercept. Always look for the y-intercept. That's the easiest reference point, especially whenever you get a line that is very steep and it is getting closer and closer to being like an x equals or a vertical line. Okay, it might be a little more difficult, or seemingly it's difficult for students to grasp if it is going to be above or below. Look for the y-intercept, and that is going to tell you what is above the line or below the line. So y is greater, you're going to shade above, or greater than or equal to. If it's y is less than or equal to, you're going to shade below. But again, look for the y-intercept and where it crosses the y-axis as your reference point. So if we have to graph the inequality and we have y greater than or equal to 2, so it's similar to y equal to 2, it's just going to be a horizontal line. So slope of the line is 0. So I'm just going to go straight to my graph, and I'm going to have a line at y equal to 2, or since it's y equal to 2, since it's included. Now if it wasn't included, it would be a dashed line. So what does it mean to be above? Well, my y-intercept is right here. Okay, so that means that it's going to be above, so that means it's going to be everything above that line. So shade everything above y is greater than 2, so it's 3, 4, so on and so forth. Whereas if it is a vertical line, so if I have x, okay, this is just going to be a vertical line, and then it's really just like old school graphing on a number line type problem. So it's a vertical line. What's the slope? Well, there isn't one since it's vertical, or it's undefined. So I'm going to have now a dashed line because it's not included. Okay, because there is no line here. Okay, it's just going to tell me. Now, again, vertical lines are pretty easy because it's going to tell you which way to shade. This is just like one big arrow. I'm going to shade everything to the right of my line. Okay, because it is vertical. Okay, so I just moved, shaded everything to the right. Now, whenever we get into actual values with graphing an inequality and we have x and y together, so it's not just a horizontal, it's not just a vertical line. So 4x plus 2y is greater than or equal to 8, so I need to get this into y equals mx plus b form. Now, granted, we can figure out and we can put our intercepts in and go about it that way and then graph the line. But it's just a matter of making sure that we know if it's going to be above or below the line. We can plug values in if we wanted to, but it's probably just as easy just to turn this into a slope y-intercept or slope-intercept form, moving the 4x over. So all I did was subtract 4x from both sides, and then divide by 2, get y is greater than or equal to negative 2x plus 4. So find my y-intercept. I'm going to go and I'm going to graph. My y-intercept is at 0, 4. My slope is at negative 2. I'm going to go to my graph and I'm going to plot my point at at 4. I'm going to go down 2 over 1, and then probably do that one more time, maybe 2, at least 1. Now, it is a solid line because it is greater than or equal to. Okay, so I have my line. Now, here is where, whenever we talk about it is greater than. So that means it is going to be, if here's my y-intercept right there, then it's going to be everything above that point, and I'm just going to shade. Okay, even though I have a greater, okay, it's still going to be down in this area as well. Okay, it's not going to change. So we just shade everything above my y-intercept. A few more examples. 3x minus y is less than 3. So move it over. Now remember, whenever we solve inequalities, if we have to multiply or divide by that negative, we have to flip the sign. If there's going to be a mistake, it is going to come right here. Okay? We have got to flip the sign when we multiply or we divide by a negative. Okay, do not forget that. That's going to be, if there's going to be a mistake that gets made, that's where it's going to be. Okay, make sure you multiply or divide. If you have to change that sign of that y, then you better make sure that that symbol changes directions. So slope is at 3, y-intercept is at negative 3. Go back to my line, plot my points, up 3 over 1. Okay, so I'm at 1, 0. Probably going to add one more point there, or I would, just to be on the safe side. Now, it is going to be a dashed line because it is not equal to. So we have to make sure that we have the dashed line in there. Okay, it is again greater. So since it's greater, here's my y-intercept. My y-intercept is right down here, so it's going to be everything above that line. So I'm just going to shade everything above that line. The hardest thing to get students to understand is that don't get into the habit of saying back, like I'm going to shade behind the line. I'm going to shade over, above, or below. Okay? And an easy way to check is just to check to see if you have a value. Like if I want to plug in 0, 0, and see if that works. Is 0 greater than, if I would plug that in, okay, it should fit my equation. Okay, so is 0 greater than negative 3? Well, you bet it is. Okay, positive or a non-negative is always bigger than a negative. So, shade everything above, and I'm good to go. So, 2/3, y is less than or equal to 2/3 x minus 1. 2/3 is my slope, negative 1 is my y-intercept. So, plot my point at negative 1. I'm going to go up 2 over 1. It will be a solid line. So, plot my points. Now, it is below. So again, it is below my y-intercept. It is below that negative 1. So it's going to be everything with negative 2, negative 4, so on and so forth. Shade below my line and go from there. Now, it says determine if the ordered pairs are solutions of the inequality. So if you have a line or a graph already drawn, okay, what I'm going to do is I can always check to see by plugging in. So x is 0, y is 1. Plug it in and see if it's true. If I plug that in, 2 plus 3, or 2 times 0 plus 3 times 1 is greater than 5. Well, 3 is not bigger than 5, so that doesn't work. So that wouldn't be an ordered pair that would be a solution. Okay? A solution is anything that is possibly on the line, depending on if it's greater than or equal to, or that is in the shaded area, similar to what we did whenever we checked the 0, 0 a couple minutes ago. So like if I have same equation and I have 4 and negative 1, I'm going to plug in 4 for x. I'm going to have 2 times 4 plus 3 times negative 1 is greater than 5. So 8 minus 3. Now, 8 minus 3 is 5. 5 cannot be bigger than 5. Okay, so this is one you've got to really pay attention that since there is no equal to part, okay, it doesn't work. It can't land on that line. Okay, it has to be above the line. So if it was equal to, then yes, then everything, if it would have the equal to, everything would be fine. But since it doesn't, It is not equal to. Okay, last one, 2 and 1. 2 times 2 is 4, plus 3 is 7, so 7 is bigger than 5, so everything works out. Okay, biggest thing here is make sure you pay attention to if it's including that line or a spot on the line, or if it is not. If it's equal to, then it can land on there and it can be equal to a value. Values can be the same. That's okay. But it's when it's not equal to that things can get a little bit tricky, even though it's not anything terrible. Assignment's just going to be 2.6. I'll attach that to Canvas, and you should be good to go.